Chapter 8, we're going to talk about chemical reactions and how to write these reactions out in the form of a chemical equation so we can describe what's going on in a reaction in a simple balanced equation. There are 4 signs of a chemical reaction. One of those is evolution of light and heat. Basically, if you combine 2 elements, 2 compounds together, and they produce heat or light, fire of some sort, then that tells you a chemical reaction has taken place. And we want to be able to describe this in an equation. Another sign of a chemical reaction is the formation of a gas. If you see bubbling or fizzing taking place in a solution, that means we're forming a gas. We're forming carbon dioxide, or maybe hydrogen sulfide. If we see the formation of a precipitate, and remember a precipitate's an insoluble solid substance that forms when we mix 2 solutions together. And the last thing that we look for is a color change. Mix 2 different solutions or compounds together and we get a different color. That means a different product has formed. So if we see one or more of these 4 things, then that tells us that a chemical reaction has taken place. And you've seen or will see all of these things in the lab this year or in demonstrations that we do in class. The law of conservation of mass is something that we've talked about since the beginning of class, and really that you've talked about since you've really started studying science in late elementary school. Basically tells us that mass is neither created nor destroyed in a chemical reaction. So essentially we have to account for all of the atoms on the right side that we started with on the left side. We can't lose any atoms. We can't make any more atoms. So whatever we start with, that's what we have to end up with. So if we look at this diagram down towards the bottom here, and if we start out with, say, 4 grams of hydrogen and we combine that with 32 grams of oxygen, we're going to end up with 36 grams of water, because 4 plus 32 is 36. So whatever mass that we start with, even though it may be in separate elements, we have to end up with that total mass as our product. And that's the law of conservation of mass. We're conserving mass. And atoms can only rearrange themselves in a chemical reaction. Can't make new ones. We can't get rid of old ones. So if we start out with 4 hydrogen atoms and 2 oxygen atoms, and we combine them, we have to somehow end up with 4 hydrogen atoms and 2 oxygen atoms. And they might be bonded differently. Notice we start out with the hydrogen atoms being separate, oxygen atoms separate, but in the end the hydrogen atoms are bonded to the oxygen atoms. Still have the same number of atoms, they're just rearranged differently. And that's what takes place in a chemical reaction. And what we're going to learn to do then later on is learn how to balance this chemical reaction to make sure that we have the same number of the same type of atoms on both sides of the equation. A chemical equation is very similar to a math equation. We add 2 or more components together. We call these reactants because they're reacting with one another. But instead of an equal sign, we use an arrow. And the arrow points to the products. They point to the substances that are formed. The reactants do not equal the products because they're different substances, but the reactants combine to form the products. Or we sometimes say that this yields the products, it produces them. So the reactants always go on the left, the products always go on the right. We use a lot of symbols in chemical reactions instead of writing them out word for word. So you're going to see a number of these symbols, and these are what they mean. Also on page 266 of your textbook, there's a whole list of more symbols than what we have up here on the slide. These are some common ones that you're going to see. So you see the arrow and the plus means and. We need to specify a lot of times what state of matter the substance is in. Is it a solid, a liquid, or a gas? A lot of times they're aqueous. Aqueous means it's dissolved in water. It means it's in a solution. So if we have aqueous sodium chloride, that means that we have sodium chloride that's dissolved in water. If a substance is heated, we'll put a triangle over the arrow. Sometimes you'll see it under the arrow, but that triangle means it's heated. If it's at a specific temperature, we'll put that temperature on the arrow. And a couple other things that you'll see, sometimes you'll see two arrows going different directions. That means the reaction is reversible, means the reactants can become the products, but the products can also become the reactants. And sometimes we may use a catalyst in a chemical reaction. A catalyst speeds up the reaction, gets it going quicker. And so we'll put that catalyst on top of the arrow, which tells us, hey, this was used as a catalyst. It's not involved in the reaction. It just gets things moving quicker. So you'll get used to writing these symbols in and recognizing what these symbols mean when you see them in a chemical equation. So when we write down chemical equations, here's what we're showing. There are three basic things that we're showing. First thing is we're identifying the substances involved in the reaction. And that is using these symbols to show how many of each that you have. And these are going to be called coefficients. So in this particular reaction, we're showing that we have two hydrogen molecules that are reacting with one oxygen molecule. When there's one of something, we don't write the one, just like you don't write a 1 a lot of times in math. But we write any number 2 or higher. And that's called balancing the equation. And that coefficient can refer to the number of molecules, or it can refer to the number of moles of those molecules. It tells us what we have, and this is where writing proper chemical formulas that we learned in the last chapter is going to be extremely useful, because we have to write proper chemical formulas in order to put in proper coefficients. And then thirdly, it tells us in what state it is. So if we look at this whole equation, it tells us that we need 2 gaseous hydrogen molecules to react with 1 gaseous oxygen molecule to produce 2 gaseous water molecules. It tells us what we have, tells us how many of each that we have, and then also tells us in what state of matter that substance is in. All this information just in that equation. And every equation that you write should have all 3 of these components written down correctly. And there are 8 diatomic elements that are on the lower right hand side of your charge sheet on your periodic table that you're given in class. These are elements that when you write them, like hydrogen and oxygen, there are always 2 of them. So whenever you write hydrogen, you write it as H2, or oxygen's O2 when you write them separate. And those 8 are hydrogen, oxygen, nitrogen, and the halogens, are what we call diatomic elements. Diatomic, di means 2, atoms mean atom, so they are 2 atom elements. Just be aware of those. All right, so we'll take this same equation that we just looked at before. We're going to use these coefficients to give us relative proportions of reactants and products. They're going to end up providing us with mole ratios when we talk about stoichiometry in the next chapter. And it's kind of like a recipe. When you have 2 cups of something to 1 cup of something else, in this case we have 2 molecules of hydrogen to 1 molecule of oxygen, or we're going to use that as the number of moles. And we'll probably use those as moles more often than we use them as actual molecules. So this slide's kind of an extension of the last slide, showing you how you're going to use those coefficients in relation to all of the compounds and all of the elements in the chemical reaction. So learning the balancing equation is just the first step in other chemical processes that we're going to look at. So here's where a chemical equation would be beneficial to us. We have a description of a chemical reaction written. 2 atoms of solid aluminum react with 3 units of aqueous copper 2 chloride to produce 3 atoms of solid copper and 2 units of aqueous aluminum chloride. What we want to do is write down this whole description in a simple chemical reaction. So we're going to start with 2 atoms of solid aluminum. Okay, so we're looking and seeing what we're given here. And we have some aqueous copper chloride, 3 atoms of solid copper, and 2 units of aqueous aluminum chloride. Okay, so we want to know how many of what and in what state of each we have. So we have 2 atoms of solid aluminum. So we're going to put the 2, we put the symbol for aluminum, and we show that it's solid after it. Even though we say solid aluminum, we're going to write it as aluminum solid in the equation. And then the key word react with. React with, that means a plus. 3 units of aqueous copper 2 chloride. So we've got 3 copper 2 chlorides, and we have to write the correct formula for copper 2 chloride. Remember, that's where we balance the charges. Copper being a +2 and chloride being a -1, so we need 2 chlorides. The symbol for an AQ, or aqueous, is AQ. And then we see to produce. So to produce, that's the arrow. 3 atoms of solid copper. So 3 of the solid copper, and is the plus, 2 units of aqueous aluminum chloride. So this formula for aluminum chloride is AlCl3. So we're showing how many we have, of what do we have, and in what state do we have for each substance involved in this chemical reaction. So we say the aluminum combines with copper 2 chloride to produce copper metal and aluminum chloride. It's much simpler to write this simple chemical equation than it is to write out that entire paragraph of what went on in the reaction. And that's why we like to write these in equation form. If we look at it the other way, we take this chemical equation, and how can we describe it? What does this show us? Well, we could write down that we have 1 atom of solid zinc, because this shows us, hey, I got 1 atom of solid zinc right here, and it's combining with 2 molecules of aqueous hydrochloric acid. HCl is hydrochloric acid. Remember, anything begins with hydrogen is an acid. So 1 atom of solid zinc reacts with 2 molecules of aqueous hydrochloric acid to produce 1 unit of aqueous zinc chloride, or we could say 1 compound of aqueous zinc chloride, and 1 molecule of hydrogen gas. So we're essentially reading this equation left to right and having it describe what's going on. So instead of writing down this whole paragraph here, we can just simply use this chemical equation and describe what's happening. Those are the benefits of writing out complete chemical equations. Always making sure that we refer to how many we've got, what we've got, and in what state that substance is.